Okay, so we'll start with electrolysis of molten compounds. Molten, the word molten means melted. Somewhere you will find in exam it is written as fused. Because in solid form, if it is lithium oxide solid, its ions are jam-packed because of strong electrostatic forces of attraction between lithium ions and oxide ions. They are in a 3D lattice, giant ionic lattice. They are not movable. Ions are not free to move, so they cannot act as an electrolyte. An electrolyte is a substance that basically let the electricity pass through because of movement of ions. So molten electrolyte, the word electrolyte mean ions, ionic substance free to move. Its ions are free to move. So we have an example like lithium oxide solid. When it is melted in molten form in electrolytic cell, it changes to lithium ion and oxide ions. Now, when the direct current is flowing, a high voltage current, and cathode is rich in electron, it's an electron market. All positive ions rush to the cathode and they are being serviced with electrons by the cathode. Depends on how much the voltage is high. High voltage, more current, more electrons, more quickly they are served, more quickly the cations are basically receiving electrons. So cation, lithium 1 plus, is given only one electron, need is 1 plus. Gets the electron back, get back to the original life, and it's a metal now. In the liquid form, because temperature of the molten cell is high. Temperature has to be kept high to keep the electrolyte in the liquid form. Ions are free to move. So at anode simultaneously, oxide ions are turning to oxygen atoms, giving off the 2 electrons. Because anion, they are negative ion, anions move to the anode, and at anode they are breaking up in the form of oxygen atoms, giving off electrons. These electrons will also move there, but these oxygen atoms combine with each other. Oxygen has to stay in diatomic form. Look at an oxide ion turning to oxygen atom, giving off electron, oxide ion turning to oxygen atom, giving an electron. You can even write this equation as oxide ion being deprived of its 2 electrons by the anode and turn to oxygen atom. But it will not come out in the form of oxygen atom for long, because oxygen and oxygen atoms combine together and they produce the diatomic oxygen molecule. It stays as diatomic. When they are in atomic form, they'll again, oxygen atoms will come again, their last shell will overlap, and they will turn into oxygen molecule again, O2. Rest of the 4 electrons are also there. So their octet completes. It means oxide ion turn to oxygen atom at anode, giving off the electrons. Oxide ion, oxygen atom, giving off the electrons. And easier for us to show, not like this, rather like this. 2 of the oxide ions we show, so turn into oxygen atom, but 1 oxide ion gives 2 electrons. 2 oxide ion will give 2 electrons, 4 electrons, sorry. So it turns to oxygen molecule. Look at 2 oxide ions. This 2 mean 2 oxide ions gives off 4 electrons and they turn to oxygen atom, oxygen molecule. Now lithium, which is obtained at the cathode, group 1 metals are silvery shiny if they ask the observation. And what care? Group 1 are very reactive, they must be kept away from air and moisture, and primarily it is used as in batteries, lithium alkaline batteries, like the mobile batteries or other rechargeable batteries. Lithium, huge reserves of lithiums are around the world, especially in US and others, and these gadgets are running on those lithium alkaline batteries. Very useful, okay. And oxygen gas is released at the anode, okay. May not be very useful product here, but oxygen's observation is what? Gas, colorless it is. Observation mean what you observe, odorless it is. Bubbles of the gas, you can write effervescence, and it basically relights a glowing splint. So electrolysis of molten compounds mean melted, fused form. There is only one type of cation and one type of anion, and one type of cation got service at cathode. Service mean getting back the electrons, and the anion at anode giving away the electron. It mean basically electrolysis in an MCQ can be asked as electrolysis is changing basically ions to what? atoms. It is changing ions to atoms. And it's a decomposition because lithium oxide is decomposed back to lithium metal and oxygen gas. Sodium chloride is decomposed back to sodium metal and chlorine gas. Or aluminum oxide may be decomposed back to aluminum metal and oxygen gas. So electrolysis basically is a process specially designed for extraction of metals and extraction of very reactive metals, because reactive metals basically make strong ionic compounds. Their compounds are strong, cannot be reduced by chemical reduction method by heating with a reducing agent, but they can be electrolyzed. And when they are electrolyzed, they are in the molten form. If aqueous form you electrolyze them, you cannot get the metal basically, because hydrogen ion is less reactive than that of the metal ion. So hydrogen ion will discharge in preference and metal ion will stay back. You want pure metal, it should be molten form. And in molten form, you will get the metal at the cathode. It is not competing with any other ion, because hydrogen ions normally compete in aqueous solutions and they discharge in preference and the metal stays back. We'll see in the aqueous solution electrolysis, but here this is electrolysis of molten compounds. Atif? हेलो भाई साहब।
सर क्या हुआ? और सर मैं चारों पर लगा के मैं तो एक टॉपिक को जरा दिखाने आया था। क्या सीन चल रहा है?
हो गया सीन मोल्टन का। हाँ, कौन सा बोला हमने? लिथियम का।